Hello kids, welcome. In this lesson we're going to learn about GCF and LCM. If you don't know what a GCF is or what an LCM is, well, soon you will. By the end of this lesson you will have a profound, which is complete understanding of these two items. Now, to start, the greatest common factor is what we call GCF. And the least common multiple is what we call LCM. Many years ago, my mom taught me about these. I wish she taught me the two methods instead of slapping me about the head when I didn't understand the first method, which I'm about to teach you. Yeah? I'm not going to slap you about the head. I'm just going to teach you, okay? Alright, so here goes. As I just said, there are two different ways of dealing with GCFs and LCMs, and the second approach or the second method is much more interesting and elegant. But the first method is very straightforward, so let's look at it. So let's begin with the greatest common factor, or GCF. And let's demonstrate with the numbers 28 and 42. So when we're talking about GCF, we're talking about integers. So we take the integers 28 and 42, and we want to know their greatest common factor, or their GCF. So what you must do in this first approach, in this first method, is you must list all of the factors of the two numbers. So you have to list the factors of 28, and then you have to list the factors of 42. And of course, by factors, I mean the numbers that multiply to make 28 and the numbers that multiply to make 42. So first for 28, these are the numbers that multiply to make it. In other words, these are the factors of 28. Factors always start with 1 and end with the number. And all the other ones are symmetric, like 2 times 14 makes 28, and 4 times 7, and there are no other factors of 28. In a second, you'll see why I have highlighted some of them in yellow. We do the same for 42. 42 has more factors. Here they are. Now you should see why I have highlighted some of them in yellow. Because 1 is a common factor to 28 and 42. So is 2. 2 is a common factor. 7 and 14. In other words, both the factors of 28 and the factors of 42 contain these numbers in yellow, right? And we want, as the name says, the greatest common factor. So although 2 is a common factor, it's not the biggest of them. Therefore, it goes without saying that the greatest common factor of these two numbers is 14. Because of all the common factors, it's the biggest, greatest. Yeah? Okay, cool. Oh, and I forgot to start my video this way, but follow Jesus Christ. He's incredible, okay? Love him. He will love you back 1,000 times more. Okay, all right, so let's look at the first approach for finding LCMs. By approach, I mean method, in case you are very young kids and still want to learn these two items. Okay, all right, so for LCM, what we have to do is, instead of listing factors of the numbers, we have to list multiples of the numbers. So we have to list the multiples of 28 and the multiples of 42. So let's start with 28. Now, notice that the factors of 28, they end, but the multiples of 28 do not end. That's why I have a ... And the way you find multiples of a specific number, for example 28, is you start with the number and then double it and then triple it and keep going that way, and you'll be able to list the multiples, although you will not finish because they go on forever, right? And then we do the same for 42. We list the multiples. I'm rushing a little. Notice that there are common multiples. First common multiple is 84. Second common multiple is 168. And there will be more and more if you keep going down this list and this list, right? If you keep listing the multiples of 42 and you keep listing the multiples of 28, there are bound to be more and more and more multiples. But as the name says, LCM, we want the smallest or the least. And it's obvious that the least common multiple is 84. Yeah? Okay, cool. Now, so then we are done with this first approach for finding GCF and LCM. As I said, the second approach is much fancier, but briefer, shorter, and cooler. It's much more elegant. So what is this second approach? I'm sure you have heard of factor trees. So using factor trees, prime factor the two numbers that you are given. So I'm going to show you that both for GCF and LCM in this second method, you need to list the prime factors of the two numbers that you're given. Or 3 if it's 3 numbers. So for 28, the prime factors are 2 2's, therefore 2 squared. This means 2 times 2, right? So there are 2 2's and then a 7. Because if you do 2 times 2 times 7, then you're going to get 28. So the prime factors, you could do this using factor trees, of 28 are 2 squared and 7 to the first. So 2 2's and 1 7, right? And then for 42, it's going to be 1 2, 1 3, and 1 7, right? And in a different video, I will discuss primes if you don't know what primes are, but I assume for this video that you're familiar with prime numbers, right? Okay, so here are the prime factors of 42. This is the prime factorization of 42, as we'd say, and this is the prime factorization of 28. Now, for GCF, what you need to do is look at the prime factorization of the two numbers and identify the primes that are the same. So the primes that are the same are 2 and 7. Notice that 28 does not have 3 as a prime factor. So for GCF, we don't consider that 3. Or any prime factors that are not in common, we don't consider them. But then what we do is we take the smallest amount of prime factors. In other words, for 28, there are 2 2's, but for 42, there's only 1 2. So we take only 1 2, and then there's an equal amount of 7, so we take that 7 and we multiply to find the GCF. So the GCF in this case is 2 to the first times 7 to the first, which is 14. Notice this is the same answer that we found in the first method or the first approach. Again, what you do is after you prime factor, you look at the common primes and then you take the smallest amount that they could both afford. So 42 cannot afford 2 2's because it only has 1 2. So then we look at the fact that 2 is a common prime, and then we take the most that both of them can afford, which is 1 2. And then we take the most that both of them can afford. In this case, it's easy because they both have only 7 to the first. I'll give you a harder example before we finish the video. For LCM, it's a tad bit more interesting. So again, you begin with the prime factorization of the two numbers, but then you take the most amount of primes either can give. I said either. If you look at the LCM, which is 84, it's made of 2 to the second, 3 to the first, and 7 to the first. 7 to the first because, well, they both have 7's, and the most that either have is 7 to the first. And if you look at the 3, 28 doesn't have a 3 to the first, but 42 does. So you still have to include 3 to the first, because one of them has it. If this was 3 to the second, you'd have to change this to 3 to the second for a different number, right? Whatever 42 times 3 would be, would have 3 to the second in it, otherwise the same kind of prime factorization as 42. Okay, my harder example, which is to come a little bit, will explain this some more. But finally, notice that 42 has only 2 to the first, whereas 28 has 2 to the second. So we take the most either of them has, is what I said. And so we take 2 to the second. We multiply these together to make 84, which again, notice is consistent with our answer from the first approach or the first method. So here's my additional, much harder example. So let's consider the number A. Now, if you want to know what number A is exactly, well, do 2 times 2 times 2, and then 5 times 5, you get it. So multiply all the 5s, all the 2s, and all the 11s, well, there's only one 11, all the 13s you see, and you'll see that A is a giant number. But again, in this second method or second approach, all you care about is the prime factorization. So I don't actually care what number A is, because all I care about is its prime factorization. And so let's take the number B and say B is this number here, or it has this prime factorization. Then, from what we said, it should be clear that the GCF is this, because, well, the common primes are 2, and then 5, and then 11, and then 13. Those are the common primes, and that's what you have to look at for GCF. And then you take the smallest that both of them can afford. So they can both afford 2 to the second. A has 2 to the third, which is a little bit more than we need, but we take the smallest that they can both afford, 2 to the second. Same with the 5s, right? We have 5 to the 7th in A, but 5 to the 3rd in B, so we take the smallest, 5 to the 3rd. And then 11 to the 1st, right? That's the smallest. And then 13 to the 2nd, that's the smallest. The 17 we leave out because, well, it's not common prime factor to both of them. Whereas for LCM, as we've already stated, you take the most either has, and if there's a prime factor that one of them doesn't have but the other has, you have to include it, i.e. the 17 to the 1st at the tail end here. But otherwise, for the 2s, we take the more one, 2 to the 3rd, right? And for 5, again, we take 5 to the 7th. You should get it by now. If you don't, ask questions. I hope this was helpful and you've now mastered finding GCFs and LCMs in 2 different ways, but use the second method because it's cooler. I will think you're cooler for doing it. Yeah? Okay, cool. I hope you enjoyed this. Have a wonderful day. Take care.